Hello students, good morning to all. So yesterday we were discussing about the ideal and non-ideal solution. In non-ideal solution, we discussed non-ideal solution with positive deviation and non-ideal solution with the negative deviation. So students, today we will discuss about the non-ideal solution with the positive deviation and negative deviation. So non-ideal solution with the positive deviation. And with negative deviation. Students, both of these are types of the non-ideal solution. And what do you mean by the non-ideal solution? Non-ideal solutions are those which do not follow Rolle's law. Means they do not follow Rolle's law. Positive deviation as well as negative deviation both do not follow Rolle's law. And what do you mean by the Rolle's law? According to Rolle's law, partial pressure of component is directly proportional to the mole fraction of that. Okay, but in case of non-ideal solution, they do not follow Rolle's law. Means either this partial pressure will be greater or it will be less. So in case of the positive deviation, partial pressure will be greater than the P naught A X A. Here pressure is greater as compared to the expected value. And PB, it is also greater than P naught B X B. P total pressure is also greater than the expected value in case of positive deviation. Students, according to Rolle's law, we drew a graph. What was the graph? According to that, we will draw the graph pressure versus mole fraction. Okay, so what type of graph we were getting? In case of PA, partial pressure of the A component, this was the graph. We have already this was the graph for partial pressure of component A. We have already discussed in previous class. And for component B, here mole fraction value XA will be 1 and XB is equal to 0. At this point, XB is 1 and XA is equal to 0. So we are taking mole fraction of B. Here, this is P naught B. And students, this is the graph for partial pressure of solvent or component B. And this was the graph for total pressure. So this was the graph for Rolle's law. And this is also followed by the ideal solution. But students, non-ideal solution do not follow this type of the graph. Here, pressure is either greater than expected value or it is less than expected value. So what type of graph we will get? In case of positive deviation, we will get this type of the graph. It will be positively deviated. In this way, we will get the graph in case of the positive deviation. Why do we get this type of the graph? Why value of the pressure is greater as compared to the expected value? Students, in case of the non-ideal solution, the interaction between molecules of the AB, it is less. It is less as in case of positive deviation, it is less as compared to the interaction between solute component and solvent component. Because this interaction is less, so we need less amount of energy to break this bond. And if we need less amount of energy to break this one, so they can be converted into the vapors easily. Because they are forming vapor easily, so they can form a number of the vapors at low pressure, at low temperature. Okay. So here, due to formation of more vapors, pressure will also be high. So students, here pressure will be more as compared to the expected value in case of positive deviation. And in case of the negative deviation, we get graph in this way. This is the graph for ideal solution for Rolle's law. But in case of the negative deviation, we get graph in this way. It is negatively deviated. Here pressure is lower as compared to the expected value. Why it is? Because here interaction between the AB particles, it is greater as compared to the interaction between solute particles and solvent particle, because here force of attraction is more, it is high, greater force of attraction is here. Due to high force of attraction, they are the closely packed with each other, and we need more amount of energy to break this, so they can generate less amount of the vapors, because they are generating less number of the vapor. So here vapor pressure will also be less as compared to the expected value. So students, in case of positive deviation, PA is greater than P naught A, XA, PB is also greater than P naught B, XB, and P total is also greater than PA plus PB. But in case of negative deviation, it will be less. Pressure will be less as compared to the expected value of the pressure. Why it is? Because here force of attraction between AB molecule is less as compared to the force of attraction between solute and solvent particles. And here force of attraction between AB is greater as compared to the force of attraction between solute and solvent particles. Here delta H mixing is greater than 0. Means students, in case of positive deviation, it is endothermic. Means amount of the heat absorbed is greater as compared to the amount of heat released. But in case of the negative deviation, this change in enthalpy is less than 0. Because here interaction is more as compared to the interaction between solute and solvent particle. So it is exothermic. Here amount of energy which is evolved is more as compared to the absorbed amount of the energy. Here in case of positive deviation, delta V, change in volume, it is also greater than 0. And in case of negative deviation, it is less than 0. Okay, students. Positive deviation. They form minimum boiling azeotrophs. Minimum boiling azeotrophs. And students, negatively deviated non-ideal solutions, they form maximum boiling azeotrophs. So what do you mean by the azeotrophs and what do you mean by the minimum boiling and maximum boiling? So now we will discuss about the azeotrophs. Students, what do you mean by the azeotrophs? Azeotrophs, they are the binary solution. Binary solution means they have only one solute and one solvent. Okay. Here solute and solvent are mixed in a fixed composition. Composition will be fixed. And if they are in fixed composition, then their boiling point will be constant. They have constant boiling point. So they cannot be separated by the fractional distillation. Student, fractional distillation is a process of separation for liquids. It is done on basis of the boiling point. If two liquids have boiling point difference less than 25 degrees Celsius, then they can be separated by the fractional distillation. Right? Why they cannot be separated by fractional distillation? Students, because here mole fraction of the component in liquid phase as well as mole fraction of the component in vapor phase becomes equal. So they cannot be separated by the fractional distillation. So what do you mean by the azeotrophs? Azeotrophs is a type of the binary solution which have fixed composition of the particles and having constant boiling point and which cannot be separated by the fractional distillation is called the azeotroph. For example, for positive deviation. Positively deviated substances solution, they show minimum boiling azeotrophs. Minimum boiling azeotrophs. What do you mean by this? Student, you know very well. In case of the positive deviation, what type of graph you will get? If we draw the graph, pressure versus mole fraction. Okay. So in case of the Rolle's law, we get this type of the graph. We get this type of the graph. But student, in case of the positive deviated substances, we get the graph in this way. It is positively deviated. Okay. So it is positively deviated. So students, here let us consider I am taking 95% solution of ethanol. 95% solution of ethanol means here 95% ethanol plus 5% of water is added into it. So here mole fraction of ethanol I take maximum, it is 1, and mole fraction of water, it is 0. And at this point, mole fraction of water will increase and finally it is maximum, it is 1. And mole fraction of ethanol becomes 0. So student, you can see here mole fraction of water is going to increase from 0 to 1. So here maximum ethanol we have. But after mixing the water, its mole fraction is going to decrease. Let us consider at this peak point. At this point, this shows the mole fraction of the 95% C2H5OH. Means here 5% of water is added into the ethanol. Okay, now if I draw the graph between temperature and mole fraction. Okay, so what will happen? Students, here vapor pressure is maximum at this point. What do you mean by vapor pressure is maximum? Here maximum vapors are getting to form, are producing. Okay, maximum vapors are forming. Why? So we can say here force of attraction between the particle is minimum because here interaction is minimum. Because interaction is minimum, so they can be converted into the vapors easily. So maximum number of vapors are forming here. Okay, students, means they have minimum force of the attraction. So at a small temperature, at less amount of the temperature, they can be converted into the vapors. Let us consider if we have boiling point of the ethanol. This is 353 Kelvin. Okay. And if we have boiling point of water is 373 Kelvin. Because at this point we are taking ethanol is maximum. So this is the boiling point of the ethanol. And this is the boiling point of the water. But student, after mixing, what will happen? Their boiling point become less as compared to their expected boiling point. Means at low temperature they get boiled. Here boiling point of ethanol is 353 and boiling point of water is 373 Kelvin. But after mixing, its boiling point is 351 Kelvin. So they boil at minimum temperature. Okay, so this is known as the minimum boiling azeotrope. It is known as the minimum boiling azeotrope. Okay, students. So from here we can say positive deviated non-ideal solution show the minimum boiling azeotropes. They get boiled at low temperature as compared to the temperature of their component when they are in pure state. But negatively deviated solution they show maximum boiling azeotrope. Students, they show maximum boiling azeotrope. For example, we can take example of 68% HNO3. Here composition will be fixed. 95% ethanol means 95% ethanol. We will take in composition is fixed in case of the azeotrope. Here I am taking 68% of the HNO3 means I have to take this one amount only. Okay. So students, you can see. This is the graph for Rolle's law. Pressure versus mole fraction. Okay. But for the negative deviated solution, graph will be like this. In this way, it will be. So student, here we will see the point where This is the graph. This is the graph for ideal solution for Rolle's law, and this is the graph for non-ideal solution. So student, let us consider here mole fraction of nitric acid is maximum, it is 1, and mole fraction of water is 0. And at this point mole fraction of water is maximum, it is 1, and mole fraction of nitric acid is 0. Okay, so they start here after mixing. Mole fraction of water it start to increase. Let us consider at this point. At this point, they have minimum pressure. So this is the azeotrope. This is the 68% HNO3 solution. Okay, students. But if I draw the graph between temperature and mole fraction, what will happen? After mixing, because they are showing the negative deviation. They are showing negative deviation. So what will happen? Here force of attraction between AB component will be greater as compared to the AA and BB components. Because attraction is more. So we need to give more energy for breaking the bond between them. Okay. So students, here more temperature we have to apply. Okay, so here let us consider this is the boiling point of the HNO3 and this one is the boiling point of the water. But after mixing, let us consider we are getting this boiling point. Means this is the point. This is the point where boiling point is the maximum. It is greater as compared to the boiling point of these two components. So they are known as the maximum boiling azeotropes. Maximum boiling azeotropes. Okay, students. So azeotropes are the binary solution of the fixed composition. They have constant boiling point. Negative deviated non-ideal, positive deviated show the minimum boiling azeotropes and negatively deviated show the maximum boiling azeotropes. Okay, so this is all about the Rolle's law. I hope it is clear to you. So thank you. Have a nice day.